Hello everyone, and welcome to Island Technologies presentation on firewalls in Draytech routers. This is part one of our two-part series of webinars on this topic. My name is Java, and I'm a technical sales specialist at Draytech Australia and New Zealand. So here we have an outline of what I'll be covering in this session. We will start by discussing firewall basics, followed by a look at Draytech firewall facilities, and concluding with a deep dive in the firewall menu. Stay tuned at the end, because me and my team will be online for 5 minutes to answer any questions. It's time to begin. Let's start now by looking at firewall basics. A firewall is a network security system that monitors and controls the incoming and outgoing network traffic based on predetermined security rules. Firewalls are usually the first line of defense in a network. They establish a barrier between secured and controlled internal networks that can be trusted and untrusted outside networks, such as the internet. Do note that firewalls cannot protect against viruses that are coming from infected media, such as an infected Office document that a staff member might bring in on a USB flash drive. Firewalls provide security by allowing and blocking traffic based on IP addresses, protocols, and ports. In this example, a computer on the local area network can easily access the internet because it's granted permission to do so, whereas an attacker who wants to access a server through Windows Remote Desktop cannot get through because they've been blocked by the firewall. Firewalls also provide security over a number of online threats, such as remote logins, Trojan backdoors, session hijacking, DOS and DDoS attacks, viruses, and cookie stealing, among others. A good description of what a firewall is and how it works is available in the YouTube video, What is a Firewall? That's been published by PowerCert Animated Videos. I'll leave a link in the description below if you'd like to check it out later. Broadly speaking, there are two types of firewalls. The first type is network firewalls. These are software applications that are running on general purpose hardware or dedicated hardware-based firewall computers. This includes Draytech routers. Some examples include the Vega 2862, the 2952, and the 2927, etc. The other type is host-based firewalls. This is usually a software that's running on one host, controlling traffic in and out of that single machine. An example is the Windows firewall that runs on the Windows OS. Other examples are ZoneAlarm, pfSense, Glassfire, etc. Firewalls also fall into different categories. The first category we look at is packet filtering firewalls. This is the simplest form of a firewall. A packet filtering firewall is typically a router that has the capability to filter on some of the contents of the data packet. The contents are in layer 3 and 4 of the OSI reference model. The type of information the firewall uses for packet filtering includes source and destination IP addresses, layer 3 protocols, that is TCP/IP protocols such as IP, ICMP, OSPF, TCP, UDP, and others. Layer 4 protocols, that is TCP and UDP port numbers. Interface of sent or received data. With packet filtering, Data packets are either blocked or passed if they match configured firewall rules. Packet filtering firewalls do have some limitations. They can be complex to configure. They cannot prevent application layer attacks. They're susceptible to certain types of TCP/IP protocol attacks. And they don't support user authentication of connections. DRATEC routers have additional firewall features that help overcome some of these limitations. The next firewall category is stateful firewalls. Unlike packet filtering firewalls, stateful firewalls keep track of the state of a connection, whether the connection is in an initiation, data transfer, or termination state. This is useful when you want to deny the initiation of a connection from external devices, but allow your users to establish connections to these devices and permit the responses to come back through the stateful firewall. And the last category is application gateway firewalls, or AGFs, which are commonly called proxy firewalls. These filter information at layer 3, 4, 5, and 7 of the OSI reference model. Since AGFs process information at the application layer, most of the firewall control and filtering is done in software, which provides much more control over traffic than packet filtering or stateful firewalls. Now that we've covered the basics, let's take a look at some additional firewall features in DRATEC routers. First, we will look at the difference between stateless and stateful firewalls. Stateless firewalls are simpler and make filtering decisions based on source and destination IP addresses, protocol, and port numbers, compared to stateful firewalls, which, in addition to everything that a stateless firewall does, also looks at the state of the data packet in the data flow. In the example shown here for a stateless firewall, when the laptop tries to connect to the server, the firewall will check that the source and destination IP addresses, as well as protocols and ports, match the rules before allowing traffic through. Firewall rules are read sequentially, so we will start at rule 1 and then rule 2 and so on. The second rule is to pass immediately. Now we look at the same example through a stateful firewall, which will associate a packet to a state and makes decisions based on source and destination IP addresses, ports, and the state of the packet, hence enhancing the security. For our example, the laptop is going to connect to the server using a telnet protocol, and stateful packet inspection, or SPI, is used. The router creates a table called a state table, recording the state of the packets passing through the firewall. In this example, the TCP three-way handshake process is used to establish a connection. When the laptop tries to connect to the server using Telnet protocol, it will send a TCP flag SYN, or SYN, to the server, which will pass through the DRATEC router. The DRATEC router then records the TCP flag in its state table and also looks into the firewall policy. When the request reaches the server will reply with the TCP flag SYN and ACK. The DRATEC router again records the TCP flag to its state table. And finally, the laptop replies with a TCP flag, that's ACK. After the TCP three-way process is completed, the telnet session is established between the laptop and the server. So what happens if the server sends a TCP flag SYN and ACK first? What will the DRATEC router decide to do with it? Since the DRATEC router is a stateful firewall, it will check its state table to see if a TCP flag SYN has been received before allowing the data through. Otherwise, the connection will be dropped. NetBIOS is a transport protocol that's used in Windows computers to share resources. It's also a popular target for hackers, and it is also used by some internet worms to infect other Windows computers. It runs over TCP and UDP ports 137 to 139. For example, if a PC running Windows wants to connect and to access a share on a file server, it probably uses NetBIOS. So DRATEC routers have a default data filter that's enabled to block NetBIOS traffic to the internet. DRATEC routers also have a default data filter called DefenseWorm, which also blocks NetBIOS traffic. This can be turned off or changed by telnetting into the router and running the DefenseWorm command as shown here. Now, inside the firewall general setup menu, we have two types of firewall filters. That's call filter and data filter. The call filter was used in the past when the internet connection had to be started before firewall rules kicked in, such as a dial-up connection. Here, if outgoing data packets matches the firewall rule, then the router will initiate a call to start the internet connection and send the packets out to the internet. Since it's no longer used, DRATEC is proposing to remove it as an option in the router. The other filter is the data filter. This is most commonly used now, since most routers now have a permanent internet connection, which is always online. Here, the data filter is applied to both incoming and outgoing traffic. This diagram shows the differences between the call filter and data filter. So for call filter, the WAN connection is initially down and needs to be brought back up before data can be sent out through the firewall. Now here's an illustration of how call filters work. We see that NetBIOS is blocked from going to the internet, so this traffic will not bring up the WAN connection. And for other traffic which is not blocked, it will bring up the WAN connection and allow traffic to go to the internet. But as mentioned earlier, this was only used for older technology connections, which were often expensive to always keep online. Let's now take a look at the firewall menu options in DRATEC routers. So the four main firewall menu options are General Setup, the Filter Setup, Defense Setup, and Diagnose. We will be going through each one of these in detail now. Under General Setup, the call filter and data filter can be enabled or disabled, and we can configure global and default rules for filtering incoming and outgoing data. Other options include always pass inbound fragmented UDP packets, as well as enabling strict security firewall feature. The strict firewall option will block data packets if the web content filter or URL filter do not act on the data going through. Firewall rules are processed in the following order. First is the data filter sets and rules. Second, routing connections that are initiated from the WAN are blocked. And third is the default rule. The default rule allows selecting filtering profiles, including QoS, WCF, that's the web content filter, app enforcement, URL content filter for data transmissions via the router. Also here, you can set the firewall to either pass all or block all by default. The pass setting is enabled by default. The filter setup menu allows the configuration of up to 12 sets of firewall rules. Filter sets 1 and 2 are the default call filter and the default data filter. A description of the differences between these two were covered earlier. The first rule in the default data filter is to block NetBIOS traffic that ports 137 to 139 from going to the internet. Other outgoing traffic will be permitted to go to the internet. Each filter set has 7 rules, so if more rules need to be added, you can continue into the next filter set. You will need to ensure that the next filter set is selected at the bottom of this menu, otherwise any following rules will be ignored. The default setting here is None and will need to point to the required filter set. The DOS defense functionality helps detect and mitigate a DOS attack. The attacks are usually categorized into 2 broad types: the flooding type attacks and vulnerability attacks. Flooding type attacks will attempt to exhaust a system's resources, whereas vulnerability attacks will try to paralyze a system by taking advantage of the vulnerabilities of a protocol or OS. Most DRATEC routers now include DOS defense and spoofing defense in the defense setup menu. Later firmware versions now have the white and blacklist option. This allows the entry of up to 16 IPv4 or IPv6 addresses, which can be allowed or blocked through DOS defense. That comes in handy when it comes to VoIP, for instance, since VoIP uses UDP for transmission. You would otherwise need to ensure that a high enough threshold for UDP flood defense is set before UDP packets are dropped, so that there is no interruption to your VoIP services. A better way to overcome this problem instead is by adding the IP addresses of the phone system to your whitelist. Now here's a sample configuration example. Firstly, go to Firewall, DOS Defense, click Enable DOS Defense, click Enable UDP Flood Defense, and enter the threshold number. The threshold is calculated according to internet bandwidth, so you may need to adjust that according to what you have. Taking into consideration any services such as VoIP you don't want to accidentally block. So, assuming we've whitelisted the IP addresses of our phone system to work out our packets per second threshold, the equation to use is data flow in Mbps times 1 million divided by 8 divided by the MTU. In this case, we have a 24 Mbps connection and our MTU is 1500. So we have 24 times a million divided by 8 divided 1500, which gives us 2000. Now, here's a general guide for other bandwidth levels. For 20 MB bandwidth, you have 2000 packets a second. 60 MB is 5000. 100 is 8000 packets a second. 300 is 25,000. And for 500 M, it's about 42,000 packets per second. That's a handy looking guide there. Now, to receive syslog alerts about denial of service, you can go to System Maintenance, syslog/mail alerts to set the syslog access. Simply click Enable, enter the server IP, click the firewall lockbox and click the OK button to apply the settings. Check the firewall syslog list on Dratec syslog utility. The network administrator will receive an alert from the router when the router is under attack. Here in the syslog, we can see UDP flood being blocked by DOS Defense. The first step in configuring the white or blacklist in DOS Defense is go to the firewall, DOS Defense, click Enable DOS Defense, and finally click the white or blacklist option. This will bring up another menu page. Here you enter the IP addresses into either the whitelist or the blacklist. Whitelist is allowed IP addresses and blacklist obviously is IP addresses to be blocked. A spoofing attack is when a malicious party impersonates another device or user on a network in order to launch attack against network hosts, steal data, spread malware, or bypass access controls. The two most common methods are ARP spoofing attacks and IP address spoofing attacks. In an ARP spoofing attack, a malicious party sends spoofed ARP messages across a local area network in order to link the attacker's MAC address with the IP address of a legitimate member of the network. This type of spoofing attack results in data that is intended for the host's IP address getting sent to the attacker instead. Malicious parties commonly use ARP spoofing to steal information, to modify data in transit, or stop the traffic on a LAN. ARP spoofing attacks can also be used to facilitate other types of attacks, including denial of service, session hijacking, and man-in-the-middle attacks. ARP spoofing only works on local area networks that use the address resolution protocol. In an IP address spoofing attack, an attacker sends IP packets from a false or a spoofed address in order to disguise itself. Denial of service attacks often use IP spoofing to overload networks and devices with packets that appear to be from legitimate source IP addresses. Dratec routers include spoofing defense under the Firewall Defense Setup Spoofing Defense menu. It includes a number of options to select for both ARP spoofing defense and IP spoofing defense. The two default options are block IP packets from WAN. The router will check if the source IP address and the coming WAN interface checks out. If not, the router will drop the packet instead of forwarding it to the internal server. For instance, if the router's local IP is 192.168.1.1 and it receives a packet from the WAN with IP 192.168.1.100, the router will drop the packet and add it to the defense log. And second, block IP packet from LAN with inconsistent source IP addresses. When receiving packets from the LAN, and with this option enabled, the router will check if the source IP and the coming LAN interface seem reasonable. If not, the router will drop the packet and add an entry to the log. Now, the firewall diagnostic menu is very useful for network engineers who want to check which filter rule is used by the Dratec router. This is under Firewall Diagnose menu, as shown here. We can verify the filter rule by using ICMP, UDP, and TCP. The direction of the packet can also be set from LAN or from WAN. and specify the source IP, the source MAC address, and then the destination IP address. You will need to fill in the required details such as direction, source, and destination IP addresses. Then simply click on Analyze to run the test. And here we have a sample screenshot of the results of this analysis. All right, that was fun. So to summarize, today we discussed firewall basics, including types of firewalls and categories of firewalls. We took a look at DRATEC firewall facilities, including data filter and call filter. And we went through the DRATEC firewall menu, including denial of service defense, spoofing defense, and the diagnostic function. For more information about DRATEC products, please check out our website at www.dratec.com.au or send us an email to sales@dratec.com.au or just give us a call on 0298 388 99. Don't forget to like and subscribe below. And if you'd like a notification of new Premiere videos we're about to launch or anytime we put up a video, please give the bell a click too. Thank you for joining in today's session. That's it for me, but please do stay tuned. Our technical team will be answering questions in the live chat on the right of your screen for the next 5 minutes. Thank you and bye for now.